Okay, I'm back, and so now we want to talk about how to locate the image of an object in either a convex mirror or a concave mirror. And if you're one of my students, you're not going to need to know these pictures, and you're not going to need to know how to draw them. But there are some general things I would like for you to know about convex and concave mirrors. You can go out and buy a convex mirror and a concave mirror, or you can get a spoon. So if you have a ordinary spoon, you'll notice that it's going to be shaped something like this. So that if you're looking into the spoon in this direction, you're looking into a convex mirror. If you're looking into the spoon in this direction, you're looking into a concave mirror. So what I want you to do is to take your spoon and hold it so that it's mimicking a concave mirror, and I want you to hold it at arm's length and look at your image in the mirror. So first, is it right side up or is it upside down? Might be difficult to tell, but no matter where you hold the spoon, your image is always going to be right side up. This is a good thing because remember that concave mirrors are used in hospitals to be able to see around corners. So it wouldn't be very good if you were to look into the mirror and you were upside down. Okay, so a convex mirror always gives you an image that is going to be right side up. It's also going to give you an image that is always going to be smaller than your head. So your head is a certain size. When you look into the convex mirror, it's always going to look a little bit smaller. And both of these features are illustrated by making a picture. So here, for example, is going to be a convex mirror, and notice I have to straddle this line. So this is my center line. I need to draw the convex mirror so that it's straddling it. Okay, then I'm going to put a candle over here, and that is going to be the object. What we want to be able to do is locate the image in the mirror. Now we're going to have two rules. So rule number one is that a horizontal line, when it bounces off the mirror, has to go through the focus. So for a convex mirror, where's the focus located at? The focus would be over here someplace. So this would be F for the focus. Okay, now we're going to make a horizontal line, and it's going to strike the mirror, and then it's going to bounce off of it. So if we were to put a flat mirror right here, it's going to bounce off in this direction. And so if we were to extend this line, it's going to go through the focus. A horizontal line, when it strikes the mirror, has to go through the focus. So that's going to be rule number one. Okay, rule number two is going to be that a line to the middle of the mirror is going to be reflected with the same angle. So let's now draw another one here. So this time I'm going to draw a line from the tip of the candle to right here. So this is the middle point of the mirror, and remember that this is equivalent to having a mirror like this. So then that means that light that's going to be coming in is going to bounce off, and it's going to go in that direction. Now incidentally, this light here is, when it hits, it's going to bounce off in this direction up there. But again, we can pretend that we could extend this line behind the mirror. So if we were to take this line here and go backwards behind the mirror, we could go in this direction, and then where these two lines come together is going to be right here. The pink one and the green one come together right there, and that is going to be where the image is going to be. So this is the focal point. This is I for image. That's O for object. And now this shows you that, notice the candle is right side up, and notice the candle is smaller than this candle over here. So your image is always going to be right side up, and it's always going to be small in the convex mirror. Now we can do the same thing. It's a little bit more tricky, but we can do the same thing with the concave mirror. So this time I want you to take your spoon and I want you to flip it around so that you're looking in this direction. And at first, let's take the spoon and hold it right up to your eye. And what you're going to see is your image is going to be right side up, and it's going to be big when you do that. Okay, this is the principle behind a makeup mirror. So with the makeup mirror, you look into it and your face is big and it's right side up. It wouldn't do you any good to try to put on your makeup if you were upside down. So it's really fortunate that it works out this way. So do you think that we could make a similar looking picture that goes with this? And yes, we can. So again, we're going to have a line that is going to be my center line here. This time I'm going to orient my curve like that. So that's going to be the concave mirror. And then where is the focus? So the focus was on this side of the convex mirror. So the focus this time is going to be on this side over here. So let me just go ahead and put a dot over here, and then that's going to be F. That's my focus for the concave mirror. So remember, the light is coming in this direction. Okay, now let's put a candle, but the candle is going to be really, really close to the mirror. So just like you took your spoon and you looked into the spoon very, very close, we need to put our candle very, very close to the mirror. How close? Inside the focal length. So if we put our object, so again, let's put a candle right there. So that's going to be O for object, and now we want to find the image. So how are we going to do it? So rule number 1 says that a horizontal line is going to bounce off the mirror, and then it has to go through the focus. So let's again use the red for this one. So a horizontal line, when it hits the mirror, has to go through the focus like that. Okay, now we can extend it back behind the mirror like this. Now you can't touch it back here, but we can imagine that this line would be extended back like that. Okay, then our second rule is going to be that a line from the candle, when it hits the mirror, is going to bounce off, and so whatever angle this is has to equal that angle right there. So it's going to look like that. Okay, now we're going to go backwards, and then where these two lines come together, that's where the image is going to be. So notice how big that image is compared to this object over here. So when you hold the spoon really close to your face, the image is going to be very, very large. And notice it's right side up. Okay, so you might be getting the idea, well, it's always going to be right side up. It was right side up here, it was right side up over here, so what's the big deal? Well, now let's take a look at the third possibility. And so this time you're going to take your spoon and you're going to move it away from your face. And if it's a really polished spoon, you will notice you are upside down now. So when you look into the concave mirror and you're at arm's length, all of a sudden you're going to flip upside down, and all of a sudden you're going to get really small. Try it. Okay? Now, I will leave it up to you to make the picture. So this time it's going to be the picture that's on the right-hand side, and it's the one that's on the top. But look at the red line and look at the green line. So the red line starts off being parallel. It then bounces off the mirror and it goes through the focus. Do you notice that the object is located where? Outside the focus. So when the object was inside the focus, the image was large and right side up. But this time, the object is over here. It's outside the focus. And so when we do our lines, we end up with an image. Notice the image is upside down. So if you're one of my students, don't worry about having to make these pictures. But you should be able to tell me that if you take a concave mirror and you hold it, out here so that it's outside the focal length of that mirror, what do you look like in it? You should be able to tell me. And then if you hold it like this, you should be able to tell me. And then if you flip it around and you look into a convex mirror, then what do you look like? So that's what I would expect that you would know. Now, the only reason why I'm showing you these three pictures is later we're going to talk about lenses, pieces of glass that are shaped into a lens. And we're going to find out you can do the exact same thing with a lens that you can do with a mirror. And we're going to use pretty much the same rules in order to explain how to locate where the image is going to be located at. And you're going to have to know how to find the image of a converging lens. And I will show you that in a few moments. You can also calculate the location of an image by using a formula. So this would be the formula that you would use in order to calculate mathematically where the image would be located at in a curved mirror. And so F is going to stand for the focus, and F is going to be a positive number for a concave mirror. So the distance from here to here, that's going to be the focus, and that was going to be a positive number. For the convex mirror, the focus is on this side, and the F would be a negative number. So you'd measure that distance, but then tack a negative sign on it. Okay, O is the object, and it's going to be a positive number if the object is in front of the mirror. And so the object was in front of the mirror, the object was in front of the mirror, so both of these would have been positive numbers. And then finally, you've got I, which is the image, which is going to be a positive number if it's in front of the mirror. And so we can use this formula, 1 over F equals 1 over O plus 1 over I, in order to mathematically calculate where the image would be. You're not going to do it. So if you're one of my students, don't worry about the formula. The reason why I show it to you is we use the same formula for lenses. And I would expect you to be able to calculate the location of an image in a converging lens. And I will show you how to do that in a few moments. Okay, let's take a break. So we have done flat mirrors, we've done curved mirrors. Now we're going to do flat refraction, and then later we're going to do curved refraction. So I'll see you in just a moment.